Then it's time to welcome Kirsi Helkala. She's a professor at Gjøvik in Norway. And many of you also remember her from December when she was also here and doing a presentation related to passwords. A method for ranking authentication products. I talked to Kirsi earlier, and well, at least to me, she made some jaw-dropping disclosures in December in her presentation. There were some things that to me was pretty amazing. And now it's like, considering Frank's talk earlier today, Kirsi is now presenting something that could be, no offense of course, but something a little more realistic on how to evaluate authentication products. So Kirsi?
Yes, thank you. Yes. So this is part of my PhD thesis, which I defended last year. And this is what I'm going to talk today. I go through a couple of example scenarios where authentication is done, challenges what companies are facing when they are selecting authenticating products, and then I will show you the method, and if we have time I will show an example of the used method. Yes. If we take a security level first and consider information which is not sensitive or confidential. Now it's very popular to lock your sport activity to net. I would consider that as a place that you don't need very strong authentication method. Even weak password will do. You will get yourself in and type in that this today I have biked 10 kilometers. Well done me. Then we have sites which contain confidential information. For example, credit card. Amazon.com, for example. I have my credit card information here. Buying books. A little bit higher security level should be needed. Currently they are using passwords, so I'm not really sure if that's high enough, but that's how it is. Then we have information which is both confidential and sensitive. If we think about our personal tax information or internet bank. So here we need a higher medium security level, level 3. And at the moment, at least what I have is a static password and one-time passcode. A little bit higher again. If you think about electronic patient journals, there is your whole medical information recorded, and those who are using it, they have access to multiple accounts. So there we need a higher security level. And in Norway, what the norm for sikkerhetsinformasjon in Health Norway actually is saying that if you are using or accessing electronic patient journals in a hospital, the level 3 is enough. But if we are accessing it in the home or a mobile application, then you need the level 4. And in the level 4, that means that then visit you speak AI. But security level is not the only one we're supposed to think. We have users. And now, if we take that Pico, for example, you said that we should use it from the screen. How can a person without arms using it? Or older people with the Alzheimer or shaking hands? We have a bunch of these people. Blind, visually impaired persons. Difficult to use. Same goes as well normal keyboard, typing passwords, or inserting cards. Your that will use, but it's very difficult to insert in a small little hole. If you think about passwords in this case, we can integrate in that way that we can save them. Then we come to this point that the security level is not the same when you're doing it at home or in a public place. At home you have a higher security level if there's nobody listening to you. But there's problems because when you are saying it, you pronounce it a little bit differently, and then there are some letters which you pronounce the same way. So yeah, there are problems. We could use the biometrics, some biometrics, not of course everybody. Everybody has everything. But then there's an issue with the cost. Who pays the bill? Is it the user who has to buy a different sensor than everybody else? Is it the service provider who pays? Then it comes to the different, what kind of service it is. Is it the commercial service or is it the state who provides the service? And then young people and old people. Young people, we learn quickly to use new systems, new applications, but how about old people? I was in Oslo rain station not a long time ago, and I bought the train ticket. We have this nice little machine where you can just click, 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 and you tell where you go, and when you go, and you pay with your credit card. It takes you a couple of minutes, 1 minute if you're fast. But there's a problem with those machines, and not actually the machines, but the system. Oslo railway station is well known for credit card thief gangs. They stand behind you in the queue, and they look what kind of password you type, and then when you're going in the train, they take your purse. They follow you. So I was there standing in that machine and doing my thing, and then there was older couple coming behind me. Could you please help us? We don't know how to use the machine. I was thinking that good that it's me. I click where they want to go, I insert the card, pay the bill, provide the PIN, and there are your tickets. Have a nice trip. So there are things to think about. And then we have an environment. We use authentication in different places, and there we have to think what kind of temperature it is, humidity, lighting conditions, magnetism. How many of you have a magnet card? How many have you destroyed? Yeah. I took this, I got Mac not a long time ago, and I was having it or carrying it in my backpack with my cards, of course, as I have done my previous computer. Within 2 weeks I managed to destroy 2, so I'm complaining this magnet here in the Mac. IT, they did not like me very much when I want to have a new card again. Yeah. And then hygienic standards needs. In hospital environment, I did my PhD in health services, so I have lots of examples from hospital. Hygienic is very important in hospital. So, for example, in operation rooms, we should have an authentication product which is touchless. The cards are not very practical because you touch them without gloves, and then you're supposed to touch with your gloves, and then you go and operate the person. That is not good. So there are a bunch of things to think about. Then I run a little survey among companies at how they actually select the authentication methods and products. And the thing is that there actually are quite lots of to choose from if you actively engage yourself to look what kind of products you have. We can categorize mechanisms in 3 basic: password, tokens, and biometrics. And each of those, they have different methods. Like passwords, we have bingos and textual password images. Tokens, here we have now already shown 2 different versions. Mechanical keys, magnet buttons. Biometrics, there we have a lot of to choose. And each of them, when it comes to the product line, has a different product. Different vendors providing the products. So, how do you choose that you will get the best, which is the best for you? What was found out in that little survey I made was that companies, they often take that what is provided from them. Vendor says take this, yes we take, without asking any about alternatives. And it also comes to this that it's very difficult to compare. It's easier to compare when you are within the same category. If you compare 2 different token products, then you have a different standard, same standards as you wish to compare. But across categories, then it's hard. How do you compare fingerprints against the password, for example?
Shouldn't be too hard.
Are you sure? Our method, what we were thinking, is that you should first take into consideration where you use it. What is your group of users? And then we scale it. So, there is the overview of the method. First, we check the user group and environmental compatibility. And then we have possible products. And then, those possible products, then we check the security level. If it's high enough for our needs, then we have a secured products. Then we take those secure products to the next stage, and we check the usability. If it's usable for users, then we have a list of usable products. And then in the end, we can check what they cost. So the first one, there we have a user, device, and environment requirements. And the user, I already hinted you that we should check our user group, what kind of work task it has, and what kind of disabilities users have. And those products which do not fit to those users, we just kick out our list. Physical environment, we have to take consideration and under consideration so our surroundings. And if the product is that it's not usable in those environmental requirements, then it's no use for us. And then also the device, what kind of size it has and memorability capacity, if we need it to be used in the long distance. So basically what you need. Then we go to security level. And that was really a bit more difficult to define. The point here is that you have to know your assets, what are they worth for you, what you are securing. And you have to decide the security level of your information you're protecting. Then you take the product and and you start determining the security level for the product. I have now mapped our security levels against NIST security levels and also consequences. Those who have done the risk analysis are probably aware of these consequences. And our method we use to, or we calculate entropy levels. So when we are determining a security level for an authentication method or a product, it is a minimum of authenticators key space and the hardness of the circumvention. Now we have those three different categories: passwords, tokens, and biometrics. So we also have own formulas for each of those. Authenticator space, key space for the passwords. That's easy for you all, right? You know how to count that. For tokens, that is the set of tokens. And for the biometrics, that is made by a column. 1 over false match rate. And we can use these, the estimation. And then the hardness of the circumvention, for the password, there we take into account effects and social engineering and guessing passwords, how easy to guess passwords. Those are those most easiest attacks against passwords. We take those and we get the entropy level. For tokens, similarly, we take the probability of that one loses a token and it's founded by a new person at Russia using it in a company and getting access. And the second one is copying the token, how easy to copy. And biometric, how easy it is, our probability, how easy to get the original sample or the forged sample. Like a fingerprint, if I'm touching a glass, how easy to take the fingerprint from there and use it in the sensor. Different sensor, different probabilities. Right? Then the usability. Here you have to talk with your users how long they are willing to use time for authentication. That they're supposed to work, right? You have a little bit more time when you are in free time. So that is dependent your users, and they set up the threshold limit here. And what we take into account in usability times is the time, how long it takes to enroll yourself in the system, set up a new password, or set up a first password, enroll a biometric, or issue a card. Transaction, how long it actually takes you to insert that or key authenticator and then gain access. Those continuing authenticators, like the PICO, there that transaction would be 0 all the time authenticating. How long time it takes you to renew authenticator, and delays made by human. If you type wrongly or insert the card on the wrong site and using a wrong finger, those are human delays. And then of course you have a system delays. You put these together. I use 1 year. You take a statistic over a year and check how long it takes. And then in the end, you have a cost. You have infrastructure costs and you have administration costs. Infrastructure costs are those when you are building a new system. There you take into account equipment, software, implementation, enrollment phase, and storage. And then you have administration costs. This goes all the time. If you have a new workers coming in, you have to enroll in. You renew, terminate, authenticator when people are leaving your company. License cost, maintenance cost. Maybe there's some other. You add those, take a year again, and check how much it costs. So that was the overview of the And then I have a little scenario here. So we can call the method once again. Let's say that we have a hospital trust having 11,000 employees. A hospital trust means that we have a single administration system, but separate units. So it's not one building, it's separate. And we authenticate the personnel, medical personnel with the electronic patient journals. And now we consider that we have a closed network and secure cables, so that we basically just talk about the user and infrastructure. And we are looking for a 2-factor or 3-factor actually. So that the first one is that we use a card to access the room with the PIN code. Then we have an actual accessing authenticator to the patient journal. And now, very important is that all the numbers I have used there, they are not from the real cases. And then say that we are looking for 3 different authenticators. Standard password, fingerprint. I have now selected the digital personal URU, 4,000 fingerprint sensor. Very finger as the recognition algorithm. And then the third one is the one-time password generator by SI. Now we were lucky. The users are capable to use all these 3. And because we are leaving out the operation rooms at the moment, and also the environment is approved, environmental requirements are fulfilled. Yeah. Now we should need that a higher medium security level, more than 20 entropy. And if we check this one, now I have assumed that we have a PIN code, that card and a PIN code. I think I forgot to type some numbers in. But let's now consider that the cards have the 11 as an entropy. And then we have a password. Let's say it's a minimum 8 characters. We take that minimum and assume that people should use all 4 character sets. And then where you get these numbers are that you have to run some kind of checkups among your users, see how vulnerable they are against social engineering attacks or guessable passwords. You have to know your risks. So these are, let's say that these are taken from that kind of analysis. So I got an entropy level 11 for the password. Fingerprint sensor. It's a 0.001% for the false match rate in that particular sensor. But we can force that. I had a master student to actually manage to dig out that number. You can manufacture a fingerprint for that sensor, so you can gain access. So that sensor got 10 entropy units. And then the last was one-time password generator. 6 digits, and it was the hard to manufacture forged copy, but you can lose it. So that's kind of from the statistical loss statistic. So it got a 13. And now when we have moved.
Question.
Yeah.
I mean, some tokens can break as well. Is that included in loss? Or?
No. Then it's not lost. Then it's unusable also for the adversary.
Yeah.
Then it's not this.
Okay.
So now you have a multi-authenticator, so you sum up entropys. Yep.
The probability for loss seems extremely low. I mean,
Yeah, but like I said, this is just an example
but
how to use.
yeah, but as this, I mean, is this per user or is it?
The whole company. What I now assumed that. Let's see what I assumed. I assumed that there are one loss per year. Then you get that. One of these lost per year.
Per person or per entire?
Entire. Those 11,000. Might be a little bit low.
It's low. No. That would be a little low.
Maybe they're very good users. Yeah, but you got the point. Yeah. So you sum up then. And in this example, they were all above 20.
Also, one question.
Yeah.
The password entropy for the standard password, is that based on what's actually being used as password, or is it possible?
Yeah, you could.
You
You
were
should-
referring to a NIST standard entropy for that as well, right?
Huh?
Or you were referring to the NIST standard entropy, right? Or-
Yeah.
Right, so that's a bit higher.
Yeah, it's high.
Yeah.
So, but if you calculate entropy for that first one, it's going to be much more than circumvention, and then the circumvention is what is taken into account. So you get that 11 from the circumvention points. Yeah. Then the usability. Now let's say that personnel are willing to wait 12 seconds for one session. If you count to 12, it's already quite a long time. But let's say that they are willing to wait 12 seconds. And in case that they have to do 8 authentication sessions per day, then they use 1.6 minutes for that. So that's the threshold that they are willing to spend. And then we compare all the times of these three against that 1.6. And there we see that the password is now too long, takes too long time to use it. So we rule it out. And then in the end, we check the cost Now I have used cost, which I found from internet. So there are no discounts available. So just adding some numbers on the web, and this is what I got. So according to this, I got 48 euro per user per year for the fingerprint sensor, and that would be our best product for that user scenario. Might be a little bit from, but again, you can.
Can I just ask,
Yes.
was this scenario also for accessing such as patient records? Or was this access to the hospital's computer systems? What was the scenario, just to
You
not
access the
specify?
patient records.
Patient records?
Yeah, but then you have to access. Okay. They have different systems what they use. They have one for the pictures and one for the laboratory and
Yeah.
one for the information. So, but this was now for the records.
Yeah.
But this is hypothetical now. They are not right numbers
Yeah.
here. Yeah. So, our method was the what I have here shown, that you can use when you compare all categories. And it really takes account the user. User has to be happy, otherwise you don't get very good security at least, and it's not nice to work if you have a bad system. And if you are interested to read, these are the papers where you can find the method and more thorough explanation where I have taken my numbers for the example. Unfortunately, they are not free. You have to pay to access. But yes, questions, more questions.
Do you have a free online web application where we can type in our own numbers to?
I have it in an Excel sheet if you want to have it. So
You have them, okay, yeah.
I'm not a programmer, so I have not managed to make this graphical.
Yeah, well, there are several programmers in here that should be up for the challenge, I guess, but
I have it in Excel.
questions for Kirsi? No? Okay, well then, thank you, Kirsi, once again.